Hi everyone, excited to be here. So I will be talking about time-driven development, which is a bit different software development process. A little bit of background before we start. So this is me. I am a proud 1X engineer, also part of Mozilla Tech Speakers since recently. That's an amazing community that promotes sharing knowledge about open source stuff, so I really recommend that you check it out. I'm also the co-founder of Adiva, which is an exclusive developers network. We work fully remotely, and we partner with companies to help them scale their engineering teams. So as part of this organization, I've had the opportunity to work with a variety of companies in different stages, from startups to Fortune 500. And that's when I realized that no matter the size, they all have the same approach to evaluating new projects, and that was always oriented around development time. So that's when I started digging more into software architecture and trying to optimize the software development processes to achieve this, like saving time on the larger scale, on team level, not only for you at the moment when you develop something. So what are we going to talk about today? The first thing is how to design software that will make it easy for you to maintain it, extend it, and modify it on the long run. And the second thing is how to know when to stop and make better use of your time. So to go through this, I will use examples from my personal experience with Adiva. The first one is developing a module for managing user profiles on our platform. So basically, when we started, we were a small local team. It was very easy for us to manage everything. We had all the data for our employees, their previous employment history and everything. So it was pretty easy, pretty simple. Once we started expanding and working remotely, this started to become a bit of a hassle for us. So it's when we decided that we need to have some more structured place, somewhere where we keep all that information for our community members and then be able to access it very easily. But we still didn't want to spend a lot of time up front to build something from scratch. We wanted to take a lean approach and learn as we go and then develop things only when we absolutely needed them. So we decided to sign up for a third-party CRM system where we would store all of our data and then create this simple interface for our users to be able to just log into the platform and manage their profile details. So this was basically how the front end looked like, and on the back end, we just depended on this single class, which was Zoho. That's the name of the CRM we used. It was just our interface towards their API. All of the CRUD methods that we needed to get the details for the candidate, their employment, and their education history. And let's see how the controller looked like. So this is basically it. It's pretty simple at this stage. Two things we need to notice here. The first one is this. We depend directly on the CRM class, and we use its methods to pull all the data we need for the candidates. The second one is that we directly depend on their naming conventions. So basically, this is not standard at all. When we move things to our local database, we would probably have to go ahead and delete all of this and change it with our new naming conventions. So this is the first red flag. We directly depend on the CRM storage and on their implementation of things. And this is on the view side. So again, we have this where it's the same problem with the names, but also we are using arrays to access this data. And if we look a bit further, when we change to a local database, we would probably need to change this as well. We would have to depend on collections instead of arrays, and all of our views will need to change accordingly. This is what happens on the update. So pretty much the same scenario. We depend on the class itself. We need to adapt everything to work with their variable names. So we're using this array to update things on the CRM side, and then we call their update method to do so. The experiences and educations have the same logic behind. It's just cut out for simplicity. So what are the red flags with this implementation? The first one is the controller knows way too much and it's open for modification. What does this mean? It means that if we want to change something, if we want to change the logic and implement a local database instead of using a third-party CRM software, we would need to go ahead in our controller and change everything we did. So it gets changed very often, and that makes it vulnerable, and it won't get stable over time. It won't get tested enough so it's stable to use. The second red flag is that methods depend directly on the CRM storage and then also their naming conventions. This is the problem we had both in the views and the controllers. And the third part is the way we access the data inside the views is different between the CRM storage and the database we will use afterwards. So let's see what would happen if we try to change the implementation and use a local database instead. Now, there's not enough time to do the changes together, but I did implement this earlier. So basically, I have this project repository where everything is implemented the way it was described on the slides. And I have a separate branch, which I call the local, where we have all these changes that we need to do to implement a local database. So first, let's see what are the files that will need to get changed. These three over here are basically the new files that we added. Those are the models that we created to access and work with our local database. The user one is also technically added, but since this is like a fresh Laravel installation, it comes with it. That's why it's shown as modified. The two things that we want to check over here are the controller and the views and all of the changes that happened there. So basically all we try to do is see what changes we need to make in our files to re-implement things accordingly. So let's do this. So as you can see, the first one, the edit function is completely changed. Everything is deleted and everything is re-implemented again. We are now depending on the Eloquent classes instead of over here, instead of using the previous CRM API that we used. And accordingly, we are passing the data to the view and using it afterwards. The update method is pretty similar. So one other thing that is very important here is that we need to change all of these names to the new ones. Over here, I made a little change in the structure as well. So the main skills and the basic overview of the candidate is now stored in a separate table with a separate model, and that's where we use the Eloquent relations to do so. So basically, the logic is a bit changed to work with the tables, and also the classes we depend on are changed to work with Eloquent. I'm just going to go through this real quickly. So basically, you can see all of the lines are red and green, meaning that everything got changed as we worked on it. And quickly with the view as well. So again, we have all of these changes that go from the naming over here until the access to the variable. So instead of using arrays, we're now using objects and the Laravel collections to access everything. So basically what this meant is to switch the storage from using a third-party CRM to using our local database. We needed to add the Eloquent models to use with MySQL, which is fine because that's what we always do when we want to implement MySQL storage. After that, we had to change all of the controller dependencies from the CRM class to our Eloquent classes and use those Eloquent classes instead of the CRM to pull the data that we sent to the view or the data that we use to update the database. We had to switch all the variables to the new naming convention, both in the controller and in the views. And we had to change the way we access the data in the views from arrays to objects. So basically, these are all the changes that we had to do in two files. And it was a lot. It was deleting everything we had and re-implementing again. So we didn't reuse anything of what we had earlier. And if you scale this to all of the other features that we implemented on the admin side as we went forward, it meant basically re-implementing everything that we used with the CRM. So it also includes all the changes on the admin features, unit tests, and everything that was done to work accordingly. So the question is, how can we save time by improving the design of the code? The first thing we can do is not to depend on concrete implementations. So over here, we depended very tightly on the CRM implementation. We knew how things were handled on their end and how the variables were accessed, and we used that inside our controller to basically create the logic around updating and displaying the profile information. So what this means in terms of code, we have this interface over here, basically creating a repository interface that will define all of the methods that we need to use to update and pull the candidate detail. We have, again, all the operations over here. And for this purpose, we can also create separate interfaces to handle the education history and the experience history. But for simplicity, I avoided that because we will always pull them together with the candidate details. So it's basically enough to have this one repository that will handle everything for us. Now, in the edit method in the controller, and we'll see the update afterwards, we depend on this interface instead of depending on the concrete CRM implementation. This means that now we can delegate everything that's done in the controller to this repository because we know what methods it provides us with, and we know that it can handle everything on its end without us having to do anything about it. A great example from real life that I like to connect with this is the dependency inversion principle, which is part of the solid design principles. And there's a great example that compares this with using electricity to plug in your computer or to charge your phone. It's basically saying that you don't need to go ahead, dig a hole in the wall, and try to wire things together because you don't care about how things are implemented in the background. You just know that you have an interface, which is the socket, and you can use it to charge whatever you need to charge and then go on with your life. This is basically the representation of it in code. We don't know how it's handled in the background. We don't care how it's handled in the background. We just know that we can count on it to do it for us. This is, again, the update method. So it's basically doing the same thing, depending on this interface instead of depending on the concrete implementation of the CRM API. So we're basically abstracting all of our dependencies. And again, delegating the update part to the proper repository. The second thing we should do, and this is again part of the solid design principles, which is the list of one. So basically, we need to be mindful about what our program expects. And if we think a few steps ahead, and if we know that we would need to implement MySQL storage and we would need to use eloquent classes, we would know that, for example, in the views, we will need to access collections instead of arrays or use different naming, etc. So basically, with this step, we want to think about that upfront to know what we want to achieve and use that to set up the initial architecture so it can be easier for us to do the changes as we go forward. So this is what I did there. Basically, I tried to mock the eloquent classes with the candidate class over here. We have up there the properties that we use inside the class. These methods over here are representing the relations with the other tables. So basically, I'm using this inside the candidate repository to be able to access all of the relationships that it has and update everything over there. And now in the views, you will see that we are able to use the relation between the eloquent models over here when we loop through all of the experience history and then use objects instead of arrays to access this. And this is great because after that, when we need to change with a database, we won't need to change anything inside these views. Everything will be defined up front and usable. So the part where the list of substitution principle comes in is basically that we are able to substitute this with a new implementation without this view knowing that something changed in the background. It will be able to keep working as is because the architecture is made in a way that supports this. And finally, to be able to implement this as is, I mean, as it's described in the steps defined previously, we need to bind the abstractions with a concrete implementation. So the way to do that is to add this binding inside the app service provider, where we state that this specific CRM repository is the one that will handle everything that's going to this candidate repository interface. And we're good. Now everything that we do depends on this abstracted repository. So let's see, after we did all these changes, how it would affect the adjustments we'll need to do in the storage. So basically, I named this the good and the bad. I'm going to go to the new repository now, which is the new implementation. And we'll see the diff again. So we have all these classes which are added, which is okay. Again, it's the eloquent models that we have to use with the, I mean, we will use with the database implementation. The user model is again modified because of that. And you will notice that the one thing that's added is this database candidate repository. So this is a good approach to extend something, is by adding new code instead of going ahead and modifying things inside it. And this is another one of the solid design principles, which states that your code should be open for extension but closed for modification. What this means is essentially that you need to be able to extend the features, the functionality of your system without changing implementation, but by adding new classes and new entities to it. The way this helps improve is that your code will get tested over time and be very stable and very resistant to bugs, so that you can just test the new models that you're adding and be good to go. Now let's see, the single change that we need to make is this one. And it's a single line. So basically, if we go ahead with this implementation, we have everything, the whole architecture designed properly. We are able to do all this, to skip all of the changes we had to do in all of the files previously, and just add a single file, which is the new repository, and do this single line change. It basically saves us tons of time, and it's much more, means that the system would be much more stable because we don't change a lot of it. So again, to recap, what did it take to switch the storage this time from the CRM API to the local database? The first one, as previously, is adding the eloquent models. The second step was creating the database candidate repository that implemented the repository interface we previously defined. So basically, this helps us know that we have something that handles everything in the background for us. The third step is to change the binding for this interface inside the app service provider. So that saves us a lot of time. It made our lives easier just because we thought things through up front and we knew how we are going to use them and implement them in the future. So knowing this, we decided to apply it in another project that we had internally that was developing a module for integrating Github. It was basically, once we started getting a lot of candidate applications, we wanted to find a way to optimize the screening process and automate part of it. So we wanted to pull data from GitHub, see repositories, see user profiles, and do some assessment based on that. Knowing what we discussed now, we decided that it's not a good idea to have everything rely on the controller. So basically, the controller shouldn't be the one that handles the logic and decides which, how things are implemented. Thinking that in the future we might need to add Bitbucket or GitLab account, we decided to create a factory that will do the instantiation for us, initialize the proper class, and then based on that, we can use all of the methods that we want to use. So this is basically what it does. Based on the type of the account it gets from the user, it initializes the appropriate class. To be able to work with this, we now have to have an abstract interface again, which will define all of the methods that we will need to use with this GitHub class. So this class will implement this interface. Whatever new class for new Git account that we will add in the future, we'll also have to implement this to be able to work as this. So with this part, we are again abstracting things and depending on abstractions instead of concrete implementation. This is what happens in the GitHub class, basically implementing that interface. And one other thing that you will notice here is this adapter. So basically, to avoid that problem with the Liskov substitution principle, with having different naming conventions between the classes, we decided to create this adapter which will prepare the input we get from the API for the one we will need to use with our application. So that's why it's added. It adds another level of complexity to the system because we need to implement this new class again and use it. So this is how our controller looks like. This is the method that basically pulls the data, shows it to the user. It's basically using the version control factory to get the type of the account that the user has. And then based on that, use that initialized class to get the proper details for the users. And this seems like a perfect design because it allows us to be able to extend it in the future, add new options for the Git accounts like Bitbucket, GitLab, whatever we want to implement in the future. We just add new code instead of modifying the existing one, and we are good to go. The problem is, 1 year after this, the code is still the same. We never needed to add Bitbucket, we never needed to add GitLab, we never needed to change anything inside this because we're not even using this feature at the moment. So basically, the whole time we spent preparing this, designing it the proper way, investing a lot to implement it this way, just it wasn't useful. Remember this? Now, this was me back then. So sometimes you just want to create something perfect. You just want to invest a lot of time into creating something that will be useful and that will be extendable. But you don't spend enough time thinking whether you would like to extend it or you would need to change it, basically. So it just means that you waste time up front without knowing what's going to happen in the future. And that's where this principle comes in. So the Agni Principle, which says that you aren't going to need it, you don't need to spend time on it. It's basically a world where both Solid and Agni and Kiss and everything can coexist. It all depends on the context, and it all depends on what you need to do and how you need to use your code to know what kind of architecture you need to build. If we go back to the first example, redeveloping it, redesigning it in a way that will allow us to extend everything was very helpful and saved us a lot of trouble going forward because we knew what we needed to do. But if you're not certain about it, if that's something you probably won't need to do in the future, then spending that time up front would really mean wasting time that you could devote to providing value to your customers or to your company. So is there a better way to do this? Apparently, using the GitHub package to pull this data, what we did previously could be done in just 2 lines. So I spent 10 minutes to set this up, and it pulled the same data that the previous complex architecture pulled. So the moral of the story is basically to understand whether we need to invest that time or we are better off if we do something faster and then refactor in the future. We spent 10 times more time to set up the thing previously, and now if we can do it for 10 minutes, it makes much more sense to go back to this once we need to extend it, refactor the code, and then move forward. So that's where the time-driven development concept comes in. It's not really something that exists, it just sounded good in my head. But basically, it's weird though, because it makes sense, at least to me. Basically what I thought with it is not that we need to develop in a way that will save us most time at the moment where we do it, when we do it. It's thinking about what will make most sense as we go forward for the company, for our team, for whoever developer comes after us and inherits our project, because doing things the proper way would mean that we save time on a larger level, and with that we are able to bring much more value to our users and our customers. So that's basically keeping the context in mind and developing with common sense and choosing the proper architecture when doing so. So this is a recap. All software development practices come with trade-offs. Most of them need you to spend much more time writing code at the beginning. So invest a lot into preparing the architecture so that you can spend much less time reading it afterwards. And that makes sense for complex systems. It makes sense because your code is much more readable, much easier to maintain, but it can be an overkill and over-engineering for simpler systems when you just need to develop something more simple. For that GitHub example, when I go back to it now, it just overcomplicated things for me. So it's not even simpler to navigate through it, because it would be much easier to do it if it's just two lines of code, basically. So know your trade-offs and use them when you're deciding on your software architecture. The second part is software design principles should simplify your life, not complicate it. So if you're using something, if you're following some principle and you see that it's complicating things, it needs you to do something more than you would if you didn't use them, then it's probably not the right way to use them. And finally, thinking about the bigger picture will help you create much more than just simple software. It will help you create value, because if you understand what you need to do and why you're doing it, you will know what would be the best way to dedicate your time and what to do to basically do more for your company and more for your customers. So it all boils down to this. Basically, software design principles are your tools, they're not your goals. So you shouldn't try to achieve them. You should not try to achieve solid or whatever else you're doing. You should just use them to achieve a better development experience and simplify your life. So how to start practicing this? The first step is to talk to your product team, try to understand the business values, why you're doing things, what you need to implement when you propose architecture for it, because based on that you will know what would be the best use of your time. The second one is always have the context in mind when designing software, because this is most important when deciding on the code design. And finally, don't blame others, don't shame them on Twitter for not using the best development practices, because they are not best development practices. What's best development practice depends on the context of the project, and what's best for you doesn't mean it would be best for everyone else. So that would be all. Thanks a lot.